In the coming weeks, if the final tests go clean, 4 astronauts could ride NASA's Space Launch System, the agency's most powerful rocket. But the real showdown isn't just who launches first, it's who can land. So here's our roadmap. Artemis II's launch window, Starship's orbital refueling milestone, and how those gates shape the first crewed return to the lunar surface. It is January 26, 2026. SLS and Orion are standing at Pad 39B at Kennedy Space Center, and NASA says the Artemis II launch window opens as early as February 6, with additional opportunities through April.
What you're looking at is real hardware on the pad and a real crew. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Cook, and mission specialist Jeremy Hansen. Artemis II is about a 10-day lunar flyby. At the farthest point, Orion will travel roughly 4,600 to 4,700 miles beyond the Moon's far side, farther from Earth than any humans have ever been. And it's the first crewed mission beyond low Earth orbit since Apollo 17.
But let's be clear on what it is and isn't. Artemis II doesn't land. Artemis III is still planned for mid-2027, though NASA also describes it as launching by 2028. And it's gated by new lunar suits and by SpaceX's Starship human landing system. The biggest technical gate is orbital cryogenic propellant transfer. SpaceX has moved cryogenic propellant between tanks inside a single Starship in space, but ship-to-ship transfer, the kind a lunar landing architecture requires, still has to be demonstrated.
That's the tension we're tracking. The government Incumbent is on the pad, while the commercial Challenger is on the critical path. Now, let's zoom in on the rocket at 39B and what has to go right between now and launch day. Welcome back. It is January 26, 2026, and in the night shot you're watching from Pad 39B, the Artemis II stack is already vertical. Orange core, twin boosters, floodlights like a stadium. Next up, a wet dress rehearsal. Getting it here is its own ritual. The crawler inches the whole stack out from the VAB, under a mile an hour, for most of a workday. This is the Incumbent, the Space Launch System. Massive, government-built, and finally getting ready to load propellant.
I call it the cathedral. It's built slowly, with ceremony, and it costs a fortune. About $4.1 billion per launch for the first few missions, per NASA's Inspector General. And for now, it's still the only rocket NASA can use to send Orion and a crew towards the Moon in a single launch.
But we're launching in 2026, not 2025. The schedule slide that pushed us here wasn't the core stage or the boosters. It was Orion, specifically the heat shield.
Right. After Artemis I splashed down in 2022, engineers saw something they didn't like on the underside. Orion's heat shield uses avcoat, an ablator, meant to char and wear away in a controlled way through roughly 5,000-degree re-entry heating. Instead, some areas shed more char than expected. NASA's root cause came down to gas management inside the material. During ablation, gases are generated, and they're supposed to vent out through the char layer. But on Artemis I's skip entry profile, heating eased off between atmospheric dips, energy built up inside the avcoat, and in places it wasn't permeable enough to let gas escape. Pressure rose, cracks formed, and bits of the char layer broke free.
So for Artemis II, did they build a new shield?
Not a redesign for this flight. Changing out the approach this late would mean a major slip. NASA's plan is to fly the current Artemis II heat shield with operational changes, basically adjust how Orion comes home, and apply manufacturing improvements for later heat shields. Think of the trajectory graphic on screen like a tuning knob. Artemis I used skip entry for range and landing flexibility. For Artemis II, they shortened that skip, reducing the time in the low heating part of the profile, so you're less likely to recreate the same heat soak and pressure conditions.
It's the classic trade. Keep the hardware, change the operations. Not elegant, but if the data closes, it's how you protect the crew and keep the mission moving.
And that's why the stack is sitting out there right now. NASA says the analysis supports crew safety with the modified entry plan. Next, the big proof-of-life test, tanking up the core stage with about 733,000 gallons of super-cold liquid hydrogen and oxygen, and running the countdown like it's launch day.
If SLS is a single roll of the dice, Starship is a factory. And 2026 is the year that factory has to prove it can do the one thing the moon mission depends on: refuel in orbit. Without that, the Starship human landing system can't leave low Earth orbit with enough propellant to go to the moon.
We hear orbital refueling constantly, but why is this the specific hurdle that defines 2026?
Because the physics is brutal. We aren't pumping gas into a car. We're trying to move cryogenic liquids, liquid oxygen and liquid methane, in a vacuum. At normal pressure, methane boils around 112 Kelvin and oxygen around 90 Kelvin. Any heat leak turns propellant into gas, which changes pressures and flow. And in microgravity, the liquid doesn't politely sit at the bottom. You have to settle it before you can reliably pull it through a line.
That's the hard part. But the momentum is real. Over the 2024-2025 test campaign, they've gone from "can it fly" to controlled re-entries and increasingly repeatable operations. Exactly what a rapid iteration program is supposed to look like.
So the rocket flies, but can it transfer fuel?
We have one concrete proof point. NASA says SpaceX completed a cryogenic propellant transfer demonstration between internal tanks during Starship's March 14, 2024 flight. And the teams have been digging through that data since.
Internal transfer is a valuable first step, but it's not the same as rendezvous, docking, and moving tons of cryogens across a sealed interface between two vehicles. That ship-to-ship transfer is the year of truth milestone.
Do we have a timeline for that test?
Not a firm published month. SpaceX has signaled it wants ship-to-ship refueling as soon as practical, and 2026 is the pressure year because NASA is now pointing to 2027 for Artemis III. But until there's a licensed flight plan on the calendar, any date is provisional.
And I'd treat month-level targets as aspirational. You need two vehicles on compatible orbits, precise navigation, stable attitude control, and thermal management while you line up the transfer, without the system drifting into boil-off, leaks, or sensor weirdness. Plus, Artemis III isn't do it once. It's a campaign. Multiple tanker flights to fill a lander or a depot, and you have to show you can repeat the whole process reliably.
Which is why that factory shot matters. Look at how many vehicles can be in flow at once. If one demo uncovers a valve issue, iteration can be months, not years, and NASA's posture reflects that. Their Starship HLS plan includes an uncrewed lunar landing demo before crew, because the agency is betting that in-space cryogenic operations are the enabling step for everything that comes next.
So, if they nail the refueling demo in 2026, the path to the landing is clear?
Not quite. Even if the pumps and docking work, NASA still requires that uncrewed lunar landing demonstration before astronauts fly on the system. With Artemis III now targeting 2027, that leaves very little schedule slack.
It's tight, yes, but if you look at the pace of progress from 2024 into 2025, I wouldn't bet against them.
Artemis III isn't late because one thing is hard. It's late because everything has to work. First time, in sequence, with almost no slack. And if you look at the critical path boxes on screen, every arrow is a potential slip.
But NASA officially reset the target to mid-2027. Are you saying that date is just a placeholder?
It's a target, not a forecast. NASA's own risk-based baseline for the lander, at a 70% confidence level, puts readiness around February 2028.
And that 70% number is conservative program management, not a guarantee of failure. It's NASA budgeting risk, not declaring defeat.
Sure, but the mission physics don't care about optimism. We aren't just launching a rocket. We're building an orbital logistics chain. Starship has to prove cryogenic propellant transfer, liquid oxygen and methane, in microgravity, and then keep that propellant usable while more vehicles show up.
And they have to do it repeatedly. It's fleet operations, rendezvous, transfer, repeat, then a precision lunar landing.
Right, and before any crew rides it, NASA requires an uncrewed lunar landing demonstration of the human landing system.
So they have to land it uncrewed on the moon first. That's a massive checklist for roughly 18 months.
It is, and we haven't even talked about the spacesuits, which can quietly become the pacing item.
Suits are basically personal spacecraft. If they aren't certified and ready, nobody's walking on the surface.
Exactly. Public reporting has the Axiom lunar suit in critical design work, with a joint NASA-Axiom critical design review around late 2025 into early 2026. That's uncomfortably late if you're trying to fly in 2027.
So if the suits slip, the whole mission waits.
Yes, Artemis III is a synchronized system of systems. SLS Orion, the lander, the refueling campaign, and the suits all have to be ready at the same time.
It's a relay race. If one runner stumbles, the baton drops.
That's why 2028 starts to look more realistic than mid-2027. It isn't pessimism. It's what happens when you stack several first-of-their-kind demonstrations and multiply the schedule risk.
So, who wins the moon race in 2026? It isn't a single rocket, not SLS, and not Starship. The real winner is whoever can integrate a massive system of systems. It's a race against physics, interfaces, and paperwork.
Let's ground this in the present day. It is January 26, 2026. Artemis II is in final pad flow at 39B, and what you're seeing on screen is the stack during rollout prep. NASA says the first launch period opens February 6th. But it's gated by the wet dress rehearsal and the flight readiness review. Then they pick a date.
That makes SLS and Orion the frontrunner for the big 2026 milestone, taking crew beyond low Earth orbit. But Artemis III? Completely different beast.
Exactly. For Artemis III to happen, we don't just need a rocket, we need a relay race to go perfectly.
It's a brutal checklist, and the graphic on screen is the point. Orion's heat shield entry plan has to close cleanly. Starship HLS has to prove it's safe, and the lunar suits have to be ready.
Don't forget the propellant. We need cryogenic transfer to work at operational scale, repeatedly, not just as a one-off demo.
So if we look at the timeline, NASA's public targets now live somewhere in the 2027 to 2028 neighborhood. Is that real?
A public date is a goal. A risk-informed baseline is a range, and that range is what you plan your life around. Watchdogs have been blunt. The lander and the suits are pacing items, and slips cascade. If refueling, docking, or suits move, the landing moves with them.
But that is the price of building a bridge. If Starship turns orbital cryogenic refueling into routine operations in 2026 or 2027, we aren't just visiting the moon, we're building the infrastructure for what comes next.
Here's the verdict. In 2026, SLS and Orion likely win the Deep Space Crew milestone. Starship wins the infrastructure game if it makes refueling and reflight boring. But the ultimate winner is integration. In 2026, we find out whether the pieces actually fit together. Thanks for watching. We'll see you at launch.